Greetings and welcome back to the lab and to the flip clock take 2 part 2. I'm happy to report that what I had here with the light on the green light on the right side here over the actual clock, it's working nicely. The only problem is it's a little on the dim side. So I was thinking about it, and ultimately what I'm going to do is on the back side, I'm going to, since there's a cavity right here, I'm going to put a potentiometer in here to control the voltage so I can adjust the brightness. Actually, it's not going to control the voltage. I should be a little bit more clear about that. It's going to adjust the current. Ultimately, with an LED and a 5-volt circuit, which is what we've got here, the LED will take the voltage at once, but we put a resistor between the 5 volts and the LED, which say takes about 3.5 volts. That means you've got a voltage drop of a 1.5. If you change the resistance, what you're actually changing is the amount of current going into the LED. It's still taking the 3.5 volts. So ultimately, after looking through my supplies, I did find a potentiometer that was a 10K potentiometer, so I can do that. But the other problem is I've got to fix the yellow LEDs. So we're going to go ahead and take this off. And now, okay, you'd think that would come off, but no, it's got the speaker. So what I've got is I've got a cavity on this side here where I'm keeping just for those that haven't seen the previous episodes, this is actually a 5-volt wall wart power supply, just wrapped in tape, just so it doesn't short out on anything. And this is wired in at one point to the 120 volts that used to go to the neon lights that were lighting the thing up, and then it runs over to, it converts the 120 down to 5 volts, and that's coming into my board, which is sitting under here, which I need to get to. That's a few more screws. If you haven't followed, this comes off, and this is just an insulator that was already part of it, and this is the circuit board that's really the key to the whole thing. So here's the 5 volts coming in to the circuit board here, and what I did was I strung along a bunch of green LEDs here and a couple of yellow LEDs. Unfortunately, the yellow LEDs didn't work out, and I just realized I need the soldering iron, and it's not plugged in. So we'll get that. So the plan, let me uncover. I gotta remember to do this in frame here. Just to uncover all of this stuff. Just throw that in the trash. And if you look at it, what I've done here is I've got a resistor going in here. That's my 10K resistor. Ultimately, what I'm going to do is I'm going to replace that 10K with the potentiometer. But what I also need to do, since the green LEDs and the yellow LEDs take a different voltage, the green LEDs turn on at a lower voltage, and what's happening when I plug it all together is the green LEDs are taking over, so the yellows never turn on. So I need to put 2 different resistors going to the green and to the yellow. I need to figure out what that difference is. So for that, I'm going to use my resistor substitution box. Let me get that right side up. That's how I determined that I liked the 10K value, and then I went and found a 10K resistor. So what I need to do is ultimately, this should be wired up to a point where I can power up the yellow LEDs, but I need to then run it from the 5-volt source. I'm going to disconnect that, and I need to run through the resistor substitution box into the yellow side so I can find the difference in value. Probably also need my meter now that I think of it. But first thing I'm going to do is I'm going to disconnect and attempt to make a connection here. Alright, looks like I gotta go get some supplies. Alright, I'm back with supplies. Actually I have this particular tester, which I kind of forgot about for a moment. I have a conventional voltmeter, or multimeter, but what this will provide for me is the ability, one, it'll provide me with some alligator clips, but two, I can actually test those LEDs. Not sure if I can test them in circuit or not, but this should be the positive. Well, it's not going to matter with this tester. I'm going to hook one up to positive, one up to negative, turn it over, and hit test on this one. And if everything works, it should blink those LEDs and then tell me what voltage I need. Okay, it failed, but it's not totally unusual for this device. Let's get it out of the way, and let's see if the soldering iron is up to temperature so I can disconnect. There we go. Okay, that worked nicely. Now I need to run, let's see, how am I going to do that? It's an older substitution box, but it still does its job. It's just that maybe the connections could be a little bit more convenient. But let's see, we've got that. Now we'll get our little grabby thing. Now we're all connected. Now the fun part is I can plug in. Alright, I am now connected. I am showing actually a red LED on the power supply, which has nothing really to do with anything. What I'm interested in is what I need to get these yellow LEDs to power up. And unfortunately, I'm already at a low voltage. I mean, a low... Wow, trying to do it and show you at the same time? That's going to be tricky. I can knock it all the way down to nothing. Yeah, there's something wrong in there. I think I may have, when I was testing it the other day, I may have actually burned out those yellow LEDs. So I think I'm going to have to rebuild that part of the board. We have most of what we need here. But I think what I need to do is take off the existing LEDs and just start over on that. Okay, what we've got here is kind of a mess. It looks like the pads came off the board when I was removing the questionable LEDs. I can always get a couple more of those LEDs. I can shape them. I can do the whole thing I need to do here. But I guess fortunately, all I'm doing is bending the leads from the LEDs over and joining into the bus, if you will. It's just a common connection all the way across. The positive. I need something to point with here. Random screw here. I have the positive up here and I have the negative down here. Ultimately, I want it to be common negative and a different positive with a resistor going into the positive on both of these. Once I get the two of them figured out, then I should be able to use the same potentiometer, which I have here, to adjust the current on both of them at the same time. So ultimately, I'm just going to grab a couple more LEDs. Let's see, no, that's red and blue. That's red and yellow. I could put red, and that would make it look really weird, but I think I'm going to do yellow. There's one. There's two. And all I'm doing on these I gotta make sure that's sealed up so I don't end up... Unfortunately, these, well, fortunately or unfortunately, it's just the nature of the game here. These are all frosted and they don't show what color they are, so you have to rely on the packaging to know what color or actually run a test. So that's why I want to make sure it's sealed up, because I got three different color three bags with three different colors. Yeah, this is messy soldering. This is not... Alright, now if I've done that right, I've still got... Let's see, I need... That's negative. That can connect on here. Let's see, how do I want to do this? Because I want to have... Yeah. Okay. I want my negative connected. I can go ahead and solder that, because that's... There we go. I do believe negative is now connected, which leaves me with the positive. And now I can start to set all this up again. So, positive, even though I'm using a green lead for positive, but it should still work. And then, use my little grabber here, grab onto the positive side of that. Let's put her up at 10K and plug it in. Alright, we've got the red light on the power supply, and I can see, that's interesting, I'm only getting one yellow LED, but it's very, very dim, so if I change the setting here, I can see it getting brighter, and I can go crazy, but for some reason I'm only getting one, not the other. So let's see what happens if I connect directly into... Yeah, that's still lighting, so it's just a solder problem on the back there. So I just need to go back after that, unplug so I'm not working on it live, even though it's only 5 volts. Move that over. I see it. Right away I can see the problem. And just somehow that very last solder connection I tried to make didn't take. So my little piece of solder and a soldering iron. And you get a nice view of the smoke. I do have an extractor fan that makes a bit of noise. So if I was sitting here doing a whole bunch of stuff, rather than breathe it in, that's what I would use. I do have enough, like I said, the other fan running simply because it's hot out and I'm trying to keep it from getting too hot right here. Alright, so now if I plug this in, or grab onto that lead, I should now be able to plug the clock in. We've got red on the power supply, and I can see they're really dim. But now I got both of my yellows coming up. So now the fun part's going to be figuring out, okay, I think I know how I'm going to do this. One point I figured out with the green, I need to do that. Whoa! That's not good. That was full power going into the green. I hope I didn't burn anything out. Be able to check in a second here. All right, they're all still functional. So this is drawing at 10K, which is what I was trying before, and if I simply turn down the resistance, then I turn up the brightness. And like I said, it's changing the current, so we can test that with the meter. And what I can do is disconnect here. Plug this lead into the substitution box. And before I do that, I'm going to put this on milliamps of current. And I'm getting negative, but that's fine. I'm getting 0.27 milliamps on the green. So ultimately what I want to do is match current for current. And at 10K, I'm pulling 0.27 milliamps, or 270 microamps. But knowing that now, I can switch from, I'm trying to do this without shorting it out again. We'll go to the yellow, and I'm pulling 0.3. So the yellow wants more. So let's try at 10K, I've got that. At 6.8K, I got 0.41. You go back there, you go back to the green. So what I'm trying to do is match the current. 0.37, 0.64. So what I really need to do is write all this down. Okay, well, let it be known that this is the point in the video at which I decided I think my style is going to have to change because my phone can't keep up with me. That, or I need to maybe change the camera mount because it's high. When it's higher up, it's further away from the fan, and when it's hot here in the lab, it just keeps overheating and shutting itself off. So ultimately, I'll tell you what I've figured out at this point. I've managed to get it working with both the green and the yellow, which is good. I got it combined. I've got it hooked up to the potentiometer, but then I realized, which I kind of knew to begin with, if I put a 10K resistor there and I have a 10K potentiometer, that's actually maximum of 20K, which would make it even dimmer. And the idea with the potentiometer was to get it to a point where it could get brighter than I had it at the end of part one. At the end of part one, I had a 10K resistor limiting the current going into the green LEDs. If I put any resistor plus the 10K, it's actually going to be dimmer. So what I'm ultimately going to do is I said, okay, let's cut the 10K in half, and that way I can get as bright as I would have with about 5K, and I can go even dimmer than I had it before. So I'll have a good sweeping range where the brightness that I had at the end of part one will be in the middle of that range. That takes care of the green. The yellow, I thought about it, and I thought about hooking up the potentiometer so it adjusts the brightness of both the yellow and the green, but ultimately at night, turning over and looking at the clock, as long as the calendar, I don't think I'm going to be needing the calendar at night, but if I want to have some light in there, I think I need to make it just slightly brighter than the green was before. So I'm going to reduce that particular resistor. Instead of putting the 3.3, which is what I ended up settling on after going through all of the measurements, and instead of a 3.3, I'll put a 2.2K on that one. I'll put, instead of a 5K here, I'll put a 4.7K. That's as close as you get with standard values to 5K, unless you want to go to military values and all the rest of that. And I don't have a set of military spec resistors. So ultimately, that's what I'm going to do. 4.7 for the green, 2.2 for the yellow. and then I'll wire up the potentiometer and I will drill a hole in the case and mount everything. So that's what remains of this project, and I'm going to get started on it. And I'll come back when I've got the next part of it done. Okay, so this might look a little odd, but now I've got the board kind of wrapped up in a bit of tape. I could put a little bit more tape here, but I'm going to go ahead and plug her in. Let's see what she looks like. I'm not 100% finished, so positive to the, there you go, that's the yellow. I'll try killing the lights here so you can see it a little bit better. There's the yellow, and I have not connected the potentiometer yet, but this will basically be the maximum brightness of the green. And so the next step is for me to wire this positive to both of these, but also to the potentiometer. And I also have to do another thing with the potentiometer here. I have this knob. Oh, let me turn the lights back on. I have this knob that should fit, but doesn't quite. But if you look at the potentiometer here, you can see, yeah, I actually cut this years. This isn't part of my old supply, and I cut this years ago. So I didn't cut it perfectly straight. I have a rotary tool I could fix that, but I think what I'm going to do first is just grab a piece of sandpaper and just kind of rub around the edges and chamfer it a little bit, so hopefully it'll fit better into the knob. Once I got that, then I also got to go get the appropriate nut and washer that go on here, and then I got to drill a hole. So there's a bunch of little things to do, but I'm going to get a bunch of that done, and I'll come back in a little bit. Okay, folks, time to start buttoning this thing up. I'm going to start putting things back in. I've got the board in here. I've already kind of shown you what that looks like. So this board's got to get up and over that. Now let's just be sure it still works. Plugged in. We got the red light on the power supply. Let me just sort of loosely put that on there. Yep, and I can see, I wonder if I can turn this so you can see it. I'm going to kill the lights. So you can see the green bar that's there, and that little bit of yellow should be just enough that if I happen to wonder what day of the month it is when I wake up in the middle of the night. Now the other thing was a question of why this is so incredibly dirty, and can I make it a little cleaner? So I'm going to take a look into that, but then after that I'm going to have to drill a hole. Let me turn the lights back on so you can see what I'm pointing at. Drill a hole probably somewhere right back here, and there's going to be this knob, so it'll just be positioned kind of like that. So that's the plan. Back in a bit. Well, can you see the problem? First of all, I wanted to actually put the potentiometer over on this side because of its arrangement on my nightstand. I just didn't want to have it right in the middle, but as it turned out, the two wires that I cut to put onto the potentiometer, I just made them a little too short. So I said, all right, fine, I'll put it in the middle. It won't be a big deal. We'll have the knob on there, but now you can see there's this huge gap. I need to shorten that shaft, which means I need to take the whole thing off again and cut the shaft down. So I'm going to take a measurement. I'm going to get that figured out, and then I'll get that taken care of. All right, folks, we're just about done here. Figured I'd bring it back in just as I'm wrapping it up. I've got it plugged in. I tested it. I've shortened the shaft. I've got an extra hole now. I suppose I could just put a piece of tape over that just to keep stuff from getting into it. We'll just do that for the moment. I've got some black tape somewhere, and wow, that was really I'm tired. I've been wanting to do this for so long, and I just was tired to begin with today, but I want to get this done. There, that should wrap that up for the moment. I can put the knob on now. Just kind of push it down It doesn't have a set screw. I don't want to destroy this, but it looks a little funky, but it's just about right. Let's see if we can find the screws. I'll finish assembling it before I turn it over and show you. Oh, don't tell me I didn't. I thought I had the screws. Alright, I'm going to have to find them. Oh, here we go. Here they are. Found them. Alright. Oop! Oh, there you go. Well, that's how I drilled the hole. I have a step bit. I started with a smaller bit, and then I used a step bit to get a nice neat hole. Now I need my Phillips. And I need to be going the right direction. Close enough. Can you tell I'm a little excited? I just want this to be done. I'm sure you've seen enough video on this. Doesn't seem like it's going exactly right, but should be close enough. One more screw. And we can put some knobs on. And let's put the selector knob on first. It's probably in the off position. Well, that's not doing much. Put the volume knob back on. There it goes. I wonder if I just hit the wrong... I've hit something wrong somewhere. Am I still plugged in? Oh, that's why. I'm not plugged in. Let me turn it down. Alright. Yeah, that could go down. There we go. Did we get anything at all on the radio? Wonder if I somehow disabled the radio. Well, that is not critical. And it may just come back on its own. Knobs were... The volume and the tone were kind of scratchy to begin with. That's a project for another day. You can hear it trying to do something. So if I get the volume up, signs of life. Well, you get the idea. And there should be one more. There it is. Just decided to hide. That goes in like that. And that one's kind of important because that's how you set the clock. But now, I can show you at an angle. I can turn out the lights. And, oh, it's resting. It's the reason it's at that perfect angle is because it's resting on the knob. But let's see. There you go. Brighter, dimmer. It doesn't get super duper bright, but that should be enough. And now I can adjust it in the middle of the night, first night, get the right level. Yeah, whatever. That's it, folks. This project is, for now, done. But the only thing left is that this here somehow needs to be cleaned on the inside. I don't know how to do it other than taking the entire thing apart again. I don't really want to do that. I've got it functional. I've got lighting in my clock. I can reset the time and go put it back in my bedroom and enjoy a nap. So until next time, have a great day.